Good day, viewers. This is Ademola Johnson. Please do remember to share this video, to like it, and to click the subscription button to subscribe. Now, we want to talk about reducing sugars and non-reducing sugars. So first, what are reducing sugars? Reducing sugars are sugars which have free carboxyl group that can be oxidized to carboxylic acid group. Now, so examples of reducing sugars are you have simple reducing sugars, e.g. D-glucose. Then you have D-galactose. So etc. Bear in mind all aldoses, all monosaccharide that have carboxylic, that have a CHO group. So all aldoses, I will discuss aldoses in our previous class. Your mannose, your amylose, your artrose, your glucose, your glucose, your galactose, your iodose, and so on and so forth. They are all simple sugar. They are all reducing sugar. And you will see, for example, in this place, look at here now, 1, this is glucose, for example, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. CHOH. You have OH, you have H, you have OH, and you have OH. You have H, OH. So, and you have H. This is D-glucose, for example. Now, this one, if we use form 2, 3, 4, 5, 6. So look at this. What makes D-glucose now a reducing sugar is that it has a free carbonyl group. What makes it CO free? Now compare it with fructose. This is reducing now. Reducing. Simple sugar. Reducing simple sugar. Glucose is reducing simple sugar, but fructose is not. 1, 2, 3, 4, 5, 6. Fructose, D-fructose, and it's a what? It's a non-reducing. What makes it non-reducing? It also has carbonyl group, but the carbonyl group is not free. Or like this one is free. What makes this one free? The carbonyl group is connected to hydrogen one side, alkyl group the other side. So it can easily take oxygen from an oxidizing agent such as Fehling solution or Benedict solution, and the oxygen it takes from there will now add up to this hydrogen so that it can form COOH, which is carboxylic acid group. So that is what makes it. But this one, this C carbonyl group carbonyl group means carbon that is double covalently bonded to oxygen. It is not free, because even if oxygen enters here, this thing cannot, because of the presence of this CH2OH, it does not give it chance to be oxidized to COOH. Therefore, all ketoses are non-reducing sugar. So as we have so non-reducing simple sugars are all ketoses with a carbonyl group that is not free to be oxidized. So the carbonyl group is not free to be oxidized. So that's that. Now let's look at number 2 example of we also have complex reducing sugars. Now these are disaccharides, or these are oligosaccharides with free carbonyl group that can be oxidized into carboxylic acid group. Example among the disaccharides is lactose. You have lactose, you have maltose, we have dextrose, you have cellobiose, and so on and so forth. So these ones they have, from the structure we drew before, their linkage, don't forget, their linkage, what makes them reducing is that the linkage between the two simple reducing sugars, residue that form them, does not involve carbon number 1 of them that carries the carbonyl group. You can watch the previous video to see what I'm talking about. In lactose now you have glucopyranose and you have galactopyranose in alpha 1 to 4 linkage. So now the glucose is using his carbon number 1 to link with carbon number 4 of the galactose, so that the carbon number 1 of the galactose, which carries the carbonyl group, is free. It's not connected, it's not used in the formation of old glycosidic bond. So it's free, can be oxidized into carboxylic acid. Then in the case of maltose, that's why this year's NECO, they asked them to produce, to test, one of the things they tested for was milk. In the milk you have lactose. So just add Felice solutions. So you can watch a previous video we did before about NECO 2024, where we tested for the presence of lactose, reducing sugar in milk. Then you will see what I'm talking about here. You will see that when you add Felice solution A and B to milk and you eat it, what happens? It turns reddish brown, showing that there is what? Reducing sugar, which is the lactose, because of the free carbonyl group of what? Of galactose there. Now, then let's look at this. Yeah, these ones are, they're not look at non-complex, non-reducing sugars. These are oligosaccharides, e.g. disaccharides without which they have already used the carbonyl. They have already used the carbonyl group of They are monomeric simple sugars to form O-glycosidic bond, and as such there is no free. So now they have used their carbonyl group to form O-glycosidic bond, and because of that there is no free carbonyl group. There is no free carbonyl group that can be oxidized into carboxylic acid group. Let's look at examples of complex non-reducing sugars. Examples of complex non-reducing sugars are 1. Sucrose, 2. Trehalose. Let's look at sucrose. Don't forget, sucrose is usually formed from the combination of your CH2OH, this is glucose that I'm drawing now. This is glucose beta in beta linkage. In beta linkage I have hydrogen here plus fructose. So here you have, you turn it to face here, you have OH, you have H, OH, and you have CH2OH, and you have H, and here you have, in beta form, you have OH down, and you have CH2OH. This is glucose, this is fructose. Now, if you can have this, in forward reaction, if you combine them, water molecule is going. Then in backward reaction, if you add water, so this combination becomes this condensation, while this is hydrolysis. Now, if you combine these two together, you have CH2OH now, then the other one, so we have HOA. So what are we doing? In condensation, water molecule is going away. And the water molecule now, the OH of this one, and one hydrogen from here. Then this oxygen will come here. So we now have this oxygen will come here, then these two things will go away. Then this bond is called, this is beta 1 to 2 linkage. And the bond is called O-glycosidic bond. Glycosidic bond. So now, it is this carbon number 1 of this glucose that has a carbonyl group. It has been used in forming O-glycosidic bond. It is this carbon number 2, this number 1, number 2 of this fructose that has carbonyl group, but it has been used to form O-glycosidic. So there is no free carbonyl group. Now, but there is something you can do to test. Now, test for complex reducing sugar. To do that, to test for complex reducing sugar, first add dilute HCl to the food sample. Why are you doing that? To hydrolyze, to digest it. So you are doing that to hydrolyze or digest the complex non-reducing sugar to produce sugars, simple sugars with free carbonyl group that can be what? Oxidized. So then, after that, after hydrolysis, then you can add Fehling solution A and B, or Benedict's solution. So when you do that, now let's go and look at what I'm talking about here. As far as these molecules like this, it is a non-reducing sugar because the carbonyl group is hidden. So but when you add dilute HCl to this, the whole glycosidic bond will break, and this will now, the glucose and the fructose will now, this is sucrose now, so will now separate apart. Then the carbonyl group that was now will now be free for the glucose, and the carbonyl group of the fructose will now be free. So when you now add, by the time you now add Fehling solutions, then what that happens? So then the simple reducing sugar then become oxidized into aldonic acid, while the copper 2 ion, which is blue, in the Fehling solution will be what? Will be reduced to reddish brown color of what? Of copper what? Copper 1 ion. So in the exam you can ask you like this. You have test, observation, and you have inference. So let's say C is the full sample plus H2O. Say C dissolves in water. So you don't know, you can say soluble substance. Soluble substance is present. Now, then you cannot say C plus H2O, the full sample is test tube. Now they now say plus dilute HCl, aqueous. No visible reaction, you will not see anything. No visible reaction. But normally, reaction has taken place. Hydrolysis has taken place. And the complex sugar have been hydrolyzed into its components, simple sugars. So that is that. So you now put what here? Dash. Then the next thing they will now say, okay, C plus H2O plus dilute HCl plus Fehling solution A and B plus heat. You now see the solution turns what? Reddish brown. You now see complex reducing sugar is present. Why are you saying complex? Why not say simple reducing sugar? Because they have asked you to add diluted HCl. So if it is a simple reduced sugar, they will not ask you. It is already in the simplest form. So that is why. So let's see what I'm talking about here. You have the sucrose here. Then they say you should add water to it. So you can see it here. So what did you see? You see that the sucrose dissolves in this water completely. Dissolves in the water. That's why we have recorded here that C dissolves in water and soluble substance is present. Then the next thing is to do what we have added water. We have also add dilute HCl, which is this. So, is there any visible reaction? There is no visible reaction. Then the next thing is to add Fehling solution A and B. This is Fehling solution A. So I'm adding it now. You can see as I add Fehling solution A, solution turns light bluish. Then I'm adding Fehling solution B. It's expected to form a deeper blue solution. Can you see? A deeper blue solution as I add Fehling solution B. So then I want to heat and see whether it will turn reddish brown color. It's already changing. I'm already seeing the color change. It's now first of all turning from blue to green, and from green it turns reddish brown. You see, it's obvious now. So from here you can identify that this is no longer blue. It's no longer green, but it's now reddish brown color of gluconic acid and copper 1 ion, which is in form of copper 1 oxide, and it is reddish brown in color. So the blue color or the Fehling solution and the Benedict solution is due to the presence of copper 2 ion. So, and when the copper 2 ion has now changed to copper 1 ion, the color of copper 1 ion is what? Is reddish brown. So that is what you are seeing there. So I hope you understand one thing or the other that we have done so far. So this brings us to the end of this class. Do remember to share this video, to subscribe, and to like the video. So, and don't forget our physical class that we have started for JAMB, for Kozueli, for WAEC in Christ Rock Academy, kilometer 8 Sapele Road, Benin City by 5 to 7:30 here. And there is constant electricity there. So, and we are there, people are there, correct, very material people are there to take each subject specialization. So, you are welcome there. And if there's any issue you want us to tackle, you can visit the comment section and put your comment there, and I will address it appropriately. Or if there's any topic you are finding difficult in chemistry and biology you want us to shed light on, you can also tell us and let us see how we can provide solution to that problem. And there is a policy we have created in the Christ Rock Academy's lecture if you are able to bring 5 candidates, you get the full tuition fee for one of them. So please, you can make that one a task, and as you see us, we will also play our own part. Then I'm always here. I'm Afe Ademola Johnson. See you at the top. God bless you, and bye for now. Thank you.